right, we are looking at proportional relationships. So our focus right now is what is a proportional relationship and what is the constant of proportionality. So linear relationships, which is just a relationship between two things. Linear relationships can be proportional or non-proportional. A proportional relationship means that there is a constant rate between the values of x and y. So constant rate between the two things. There's a pattern between them. Now there's a lot of names for this constant rate. It can also be called the constant ratio, or it could be called the constant of proportionality. And I have the letter K here because constant of proportionality is a mouthful. We can use the letter K to represent what that means. Okay, we can call it a constant ratio because it is a ratio. It's a ratio of your two items. It's a ratio of your y over your x. So think of it as your dependent variable over your independent variable. In a non-proportional relationship, there is no constant of proportionality, so you do not have that pattern. Okay, so if you have a proportional relationship, you have direct variation. Direct variation exists when a relationship is proportional. So I'm giving you a lot of ways to say the same thing. Proportional means it's direct variation. And so you may hear the phrase, especially in a question, saying y varies directly with x. That's just your clue that you have a proportional relationship. You have a direct pattern between the two pieces, the two values you're looking at. Okay, so a deeper look into the constant of proportionality or your constant rate. Those situations that are proportional and vary directly can be represented by an equation. That equation is in the format y equals kx, where k is that constant that we're talking about. So that's what this is. The coefficient k is the constant of proportionality, which, like we said, is y over x. Okay, so in this template, you would have a number here. You would have y equals a number and x. That's your equation. And so that number, notice it's being multiplied by x because this number, your constant of proportionality, is your multiplication pattern. That's the whole point of proportional relationships. There's a multiplication pattern. So I'm going to write that multiplication pattern. Okay, so we're going to look at that. Sometimes it's helpful to understand what a proportional relationship is if we can compare it to a non-proportional relationship. So looking at the equations, like we just said, it can be written as y equals kx, where the k is your rate of change. We also call it slope, but that'll come later. So the rate of change. So what that would look like is y equals 5x. That's an equation for a proportional relationship. Now it could also look like y equals 1/5 x. You can have a fraction there, which means it could also look like y equals x over 5, because 1/5 x is the same thing as x over 5, because remember there is that invisible 1 right there. So lots of different ways to write an equation, but the gist of it is it's just a number and x. So a non-proportional equation would be in the format y equals mx plus b, where m is your slope. It's not the rate of change, it's just the slope. And you have something added, b, it's not 0, it's an actual number. So again, a real life example, you'd have y equals maybe 5x plus 1. So notice the difference between these two is a non-proportional has something added or subtracted, so we could have y equals 5x minus 1. Okay, you could also have just y equals x plus a number, like plus 1 or minus 1. Because again, there is an invisible 1 right there, so just because you don't see a number, you could have just plain old x. but as long as something is added, it's not proportional. So that's your equation. Now looking at a table, this table is a proportional relationship because of that pattern. There's several things you can look at. On this one, it's pretty easy to see the pattern going from 2 to 6, 4 to 12, 6 to 18, 8 to 24. They're just multiplying this by 3 every time. Okay? That's your clue that it's proportional. Now, not all tables have such nice numbers where you can spot that pattern right away. So if they don't, you just have to look, is the y over x constant? Meaning if I take the y value of 6 and I put it over the x value of 2, does that give me the same answer as when I take the y value of 12 over the x value of 4? And it does. Same thing, 18 over 6 and 24 over 8. All of those equal 3. So it's a constant pattern. It's a constant ratio. That means it's proportional. And again, I just want you to notice that ratio of y over x is 3. That's your multiplication pattern. Okay, so everything kind of ties together. I know it's very wordy, but it's really not as complicated as it seems. It's really just looking at a pattern. Does it have the same pattern? So then looking at a non-proportional example, there's not a constant pattern here. If I take 2 times 4, that would give me 8. But if I take 4 times 4, that does not give me 14. If I take 6 times 4, it does not give me 20. There's not a constant pattern. Again, that ratio of y over x. If I take 8 over 2, that does not give me the same thing as if I take 14 over 4. 8 over 2 is 4. But 14 over 4 would be 3.5. So they're different numbers. It is not a constant ratio. So that's non-proportional. This one has a pattern. This one does not have that multiplication pattern. All right, on a graph, this one's pretty easy to spot for a graph. Any graph that is both linear and contains the origin is proportional. So linear has the word line in it because it means straight line. Linear just means it's straight. So I'm going to write that. So if it's straight and contains the origin, which is just 0, 0, then it's proportional. So this line right here is straight, and that's the origin. So that is proportional. Now, non-proportional is any graph that is not linear or does not contain the origin. I'm emphasizing or because looking at these examples, here's an example. This is linear. This is a straight line, but it doesn't go through the origin. This one is not linear, but it does go through the origin, but because it's not linear, it doesn't count. Okay, now you could have a combination of both, I guess, where it's not linear and not through the origin. That would be something like that, kind of the U down below. So you can have different variations, but if it doesn't have linear or it doesn't have origin, it's disqualified. Okay, so that is the basics. Now let's look at some problems and the problems you would be given, these word problems. I think this will kind of help you understand what does all this mean because it connects it to real life. So word problems. To determine the constant of proportionality from a word problem, find the ratio of the dependent, which is your y, to the independent x, and then you simplify, which usually just means you divide. Now here's the big thing right here. It says find the unit rate, because that's all the constant of proportionality is, the unit rate, the amount for one of something. Okay, so reading this problem, it says Julius buys 10 pieces of gum for $2. He buys another 15 pieces of gum for $3. What is the constant of proportionality and what does it mean? So it's just asking, what is the unit rate? What is the amount for one? So in this specific situation, what is the amount or the cost for one piece of gum? That's what we're solving. So thinking of it as the cost per piece of gum. So I'm going to write that out in fraction form to help us organize our numbers. Now I know that the constant of proportionality, K, is y over x, but this problem doesn't specify which one is y, which one is x. A lot of problems do, but not this one, but we can just use our reasoning skills to figure that out because we're looking for the cost per piece of gum. So we write it in that order. The cost, which is money, I'm just going to abbreviate with the money sign, per, think of that line as per piece of gum. Another way that you could realize that the money is your Y value and the price is your X is because it's talking about dependent and independent. Independent is what you choose. I'm choosing how many pieces of gum I want to buy, and then the cost is the result. That's dependent. That's another way to look at it. But again, most problems tell you which one is X and which one is Y. Okay, so we have it set up, so we just put our numbers in the appropriate place. So we know that 10 pieces goes for $2. So 2 is the money amount that goes on top, 10 pieces goes on the bottom. You can solve that and find K. So 2 over 10, or 2 divided by 10, is 0.2. We can also do that with the other numbers that they give us. We don't have to though, because this is proportional, it's gonna be the same amount, but just to prove that, $3 for 15 pieces, if you take 3 divided by 15, it is also 0.2. So that's your constant of proportionality. K equals 0.2. But what does that mean? Like I said, we just found the amount for 1. So we could rewrite this because this is the cost for 1 piece of gum. So this we could write in money format as 20 to be 20 cents. So it is 20 cents per piece of gum. That's what it means when it's asking for the constant of proportionality, just the cost for 1. Okay. Now the next one, the last one, it says 2 dozen donuts cost $18. 3 dozen donuts cost $27. What is the constant of proportionality and what does it mean? So same idea, constant of proportionality is K, which we discussed is the Y over the X. Now again, it's really just the amount for 1 of something. So what would make more sense here? Do we want to know how much 1 dozen donuts cost, or do we want to know how many dozen donuts we can get for $1? It seems kind of silly to figure out how many donuts you can get for $1. It's more common and makes a little bit more sense for the cost for 1 dozen donuts. So that's the order we're going to go in. The cost for 1 dozen donuts. So the cost per dozen. So then we just start with what we know. We know that 2 dozen cost $18. So I have to put it in the appropriate order. The dollars is first, then 2 dozen. And so that's 18 over 2, or 18 divided by 2, that's just 9. We can do the same thing with the other info that they give us, but it should be the same amount because it should be constant, the same. So $27 for 3 dozen. And 27 divided by 3 is 9. So our constant, our K, is 9. But again, that just means it's $9 per dozen. Your fraction, the units you've set up in the fraction, kind of helps you with the words as well. It is $9, dollars is first, per dozen. The amount per 1. Okay, that is constant of proportionality and proportional relationships, just a general overview.